Today I want to teach you about how to perform a goodness of fit test, which is an inferential procedure used to determine whether a frequency distribution follows a specific distribution. And for goodness of fit test, we'll be using the chi-square distribution, which has the x sign with the square sign at the top. And this is an example of the chi-square distribution. As you can see, it is not symmetric, and the shape of the chi-square distribution depends on the degrees of freedom, just like the student's t-distribution. And as the number of degrees of freedom increases, it becomes nearly more symmetric. As you can see, the graph with the 30 degrees of freedom is almost symmetric, and the values of the chi-square is non-negative because it's squared. It will be 0 or greater than 0. Before we go any further, we have to learn about the expected count. And the I just shows a symbol of the category, the number of the category, and the expected count will be basically n times p, which is the number of independent trials times the probability. So for example, if I was to roll a die 100 times, the probability of getting a 1 will be 1 out of 6. And if I roll the die 100 times, I'll be getting 1 about that many times. And that would be the expected value of me getting a 1 if I rolled 100 times. In order to test for the statistic, we're going to use chi-square equals the sum of the observed value and minus the expected value, and then we're going to square it and divide it by the expected value. In order for us to do that, we have to make sure that all of the expected values are bigger than 1 or equal to 1, and no more than 20% of the expected frequencies are less than 5. For example, if this was the null hypothesis, and then we have the observed counts and the expected counts, and we're going to test for the statistic as such. And we're going to find out that the level of confidence of this problem was 5% or 0.05. And since the critical value that we found was 2.903, and the critical value for the level of confidence is 7.815, and the critical value 2.903 does not fall to the right of 7.815, we're not going to reject the hypothesis.